We'll be starting shortly. This is the SEPS to BIM, Space and Equipment Planning System, and BIM. Today we'll be focusing on demonstrating how SEPS data flows into tools such as Attainia, Revit, Navisworks, Onuma, and SketchUp. This is a presentation hosted by Attainia and Onuma, Inc. My name is Pmo Onuma. I'm an architect of Onuma, Inc. Today we'll have Michael Blair from Attainia presenting, myself and my team, Thomas Dalbert and Youngkoo Kim, and Ryan Gear from SketchUp. Some of you have been following what we have been working on with the Department of Veterans Affairs and Department of Defense Military Health System. It's a series of projects that look at the entire life cycle of a project, all the way from the early planning phases through design construction and also into operations. Today we'll be focusing mainly on the SEPS, the Space and Equipment Planning System, that defines the programmatic requirements of a project, a healthcare project. But if you replace the name of healthcare with any other type of project type, it applies. The same kind of workflows apply. What's really interesting about this work with the SEPS project is that the actual owner database, their programmatic requirements, is for the first time accessible directly on the web through web services, linking live to their data, which is a foundation of being able to move data consistently all the way through the project lifecycle, including the early design into design and construction. And as an architect who has been working with BIM for over 20 years, I see this as an incredible opportunity to really use the information aspect of BIM and move owner data into the design and construction phase, but also track it through and deliver it back to the owner, which a lot of owners are obviously looking for. How do we use this data as it goes through the entire project and also into operations? So a quick review of some of the basic principles that we looked at in our work with through the National Institute of Building Sciences for the Department of Defense and the Department of Veterans Affairs. This is a White House document. The White House did not invent this concept, but they latched on to how basically the internet works, of making data accessible to many applications. This is called a three-tiered architecture. Conceptually, it's the idea of keeping data in a neutral format that can be accessed by many different applications, not encasing it into a single application, not fusing it into a single application, but making it neutral and accessible as what's called an information layer, and then having a platform layer, an API, and web services and other tools that other tools can get to, many different applications, so many different users can access that. So applying this to SEPS, the Space and Equipment Planning System, which is used by the Department of Defense and Department of Veterans Affairs to define programmatic requirements for healthcare facilities, which are obviously very complex with a lot of equipment and spatial requirements. And over the last 2 years, the SEPS tool has been moved into a platform that is accessible on the web on max.gov, and they've also opened up parts of the database to be 100% public. And this was pretty interesting because we guided them towards conceptually saying, okay, if you have programmatic requirements of how hospitals are put together, what goes into an exam room, and it's the requirements that are already published as a PDF, why not make that actual data accessible so we're all talking about the same information? And this makes for a much smoother potential workflow for everybody in the life cycle of a project, all the way from the owners defining the requirements to communicating it to the architectural team, and then for the architectural teams to work with this as well. So the VA, for example, has a technical information library on the web, a lot of really great information there, but it is stuck in more of a static PDF format, and these documents are constantly changing, so it's going away from static documents and breaking down silos. And the silos can be in many different formats. If you have static documents, you need to pass it to somebody else, either as a PDF or even a BIM can be static. So if you have data inside a BIM and you need to pass it from one team to the next, we all know that's a challenge. But if you think in terms of all of that data, instead of being encased in the model, being accessible to many different models and many different teams and many different end users, even the customers, the patients, for example, in the hospital might want to be able to find where that exam room is in the hospital, and then the facility team might want to be able to say, where is that piece of equipment that's failing, where's the VAV box, or where's that pump that's failing in the building. It's the same type of information but accessible to different types of users, and obviously there's security wrapped around all of this. And SEPS is interesting because SEPS is the space and equipment planning system, the data of the owner that essentially starts this whole process. If you have consistent data, then you can start layering it into an ecosystem that allows many applications to actually access it. And that's what we're going to focus on today. Today's presentation is the second in a series. The first one was a little bit over a month ago that focused on SEPS and the moving it into SketchUp. We'll show a little bit of SketchUp at the end of today's session as well too. But the SEPS data, the owner's space and equipment planning system data for a hospital is now directly linked to BIM and directly linked in a live way as well too, either live or you can take it offline as well, but we're going to show how this is possible today with this connection. And this is important for an owner, obviously for a healthcare facility. There's a lot of very complex data that is constantly changing. So as healthcare requirements change, from an owner's side, if you say, okay, we have a new requirement for a boom arm in an exam room, for example, this changed. We no longer use JSN D600. We use something else that looks more modern, an LED light, for example, instead of an older style light. Those requirements are constantly changing, and embedding that data into a static format, even encasing it into a BIM object and saying, well, here's 2,000 families of BIMs for Revit, for example, and having that data encased in it is problematic because then if you have to maintain and update it, it becomes very time-consuming. So having the SEPS data on the web and making it accessible and making the equipment standards accessible changes absolutely everything, because now as a designer, if I'm wearing an architect's hat, I don't have to spend a lot of time chasing information around. You basically have access to the latest information. And obviously this is going to evolve over time, but conceptually what has happened is a series of BIM objects of all the equipment types that are in SEPS. There's 2,000 pieces of equipment, and there's standard templates. What does a standard exam room look like? Those are saved as templates, but also driven from a database. So as changes happen in SEPS, those templates get updated. And as project-specific requirements come out of SEPS, you can also link them to the templates. So today we'll show how this process can flow into the Onuma system, which is a web-based BIM application in the cloud, and then also link to other applications such as Revit, Navisworks, and SketchUp, and all have the same data. So when you open up a piece of equipment in Revit or Navisworks or SketchUp or Onuma, you would have the same SEPS data in it, and the designer can focus on working on the design. MIL Standard 1691 on the left is the equipment database. This is also publicly accessible on the web, either as an application that you can search for equipment or as what's called a web service, which is a machine-readable database that other applications can link to live. And these standards are being cataloged, and it's a work in progress, but there's new departments coming online from the VA, for example, and as these are being added in the future, the templates will be updated. But there's already a substantial amount of information already there for every single room type and every single piece of equipment that's accessible now through SEPS to BIM. So today we'll be showing the SEPS to BIM process into Onuma, Revit, SketchUp, and the first time introducing another app, the first actual application outside of this first few sets, that's Attainia, which is an equipment database, medical equipment database, which is used by healthcare facilities around the world. And Michael will explain that later on. Conceptually, what we have is in the cloud, these tools are accessing the same information. So as the SEPS data changes, it's important to think in terms of you don't want only BIM experts to get access to this. And this is becoming common now with mobile applications. The expectation is that we need to get to this complex data regardless of what application we use, what tool we use. And that's where we are today. So a little introduction to the Onuma system. This is one of the tools that we'll be showing. This is something that we've been using for many years in-house in Onuma, and also licensing it. You can actually get a license on the web. We have what's called our own BIM server that stores information, and that BIM server feeds into web applications, desktop applications, and mobile applications that you can actually see the BIM data. And this BIM server then can be linked to tools such as Revit as well. So for example, you can have data in the BIM server about a piece of equipment that is either in the Onuma server or linked from the Onuma server from the SEPS data, from the 1691 data on their server. And then you can also open up Revit and link to the same BIM server. The end user doesn't necessarily need to know all the technicalities that are happening in the background, and that's one of the big goals of this, is that as you make these tools simpler to use, the end user has more capability to access information regardless of what tools they use. And now let's switch away from the PowerPoint and head into some live demonstrations. So first of all, there's a site called SEPS2BIM.org. This is completely public. You can actually get to it and take a look yourself, but let me walk you through it quickly to explain what this is all about. On the Seps2BIM site, there is a series of tabs. It's kept very simple. Conceptually, it's explaining what all the pieces are. There are objects, 2,100 objects. Out of the 2,100 is about 1,000 of them that have more detailed geometry associated with them. There are templates, over 1,100 space templates for VA. There are departments, which are collections of templates, and then there's a project tool as well too. And it's a direct pipeline into healthcare owner data. And there's a great introductory video that was produced by VA explaining kind of the overall concept. And remember, I'm talking about VA and healthcare facilities, but this process applies to any project type. We're kind of focusing on healthcare right here, but the concept is exactly the same. At the very bottom, there are links to, for example, the owner's website, Seps2BIM on the VA till, where you will see sample files, introductions, and guidelines, and downloads that you can make about their process using the Seps2BIM tools and data. And there are links to the live web services and everything that I mentioned earlier. But I want to focus right now on a couple of very simple things here. One is the Objects tab, and gives you information about the different BIM objects that are available. There are 2,100 in Revit and in SketchUp format and in Onuma format. You can actually download the Revit families. You can go to SketchUp 3D Warehouse, for example. Let's open this up because this is kind of interesting. These are the exact same objects in SketchUp that are in Revit with the same IDs and everything. And that was part of the effort here, was to get the naming consistent. And the naming is consistent because we're linking to the government 1691 database, which is essentially what do we call all of the Revit, all the BIM objects that are being used for VA and DoD. There's a consistent naming structure for the 2,000 objects. And then the templates are a series of generic templates, generic layouts that VA has been building with our support, again, in Revit, Onuma System, and SketchUp. And these are both static templates are available, but the most interesting one is the dynamic templates, which I will demonstrate next. And dynamic, meaning that if you go and you have 2,000, let's say you have 2,000 REM templates, if you save them as static BIM templates, then if a change happens to a piece of equipment tomorrow or next year or a week from now, then you'd have to go back and manually update the templates. What we've set up is a process where as the database changes on the SEPS side and 1691 side, it feeds into the BIM server that I mentioned earlier and then feeds into the templates. So on the fly, you could get the latest generic, what does an exam room look like in VA? And these are before we even hit the project requirements. This is kind of the what's in SEPS, what's in the 1691, how does that equipment look? And then there's a series of tools. These are publicly accessible tools on the web to what we call 3 different tools. There's a space and equipment aggregator, which basically you can go and grab a typical space and equipment. Another one is a department aggregator. Says, let me I'd like to see the latest that is known of the dental department, for example, for VA. And another one is an actual project generator. So let's walk through these one by one. At the very top, space and equipment. And in the space and equipment aggregator, you put in your email address. And there's about 2,000 room codes. There's some samplings here, but you can actually search. There's other buttons here. You can actually search any room code. But let's say we want to pull up a dental exam room. I know it's DNTG1. And you hit proceed. And what this does is it's sending the data to multiple servers and to the Onuma server, for example, and it just created a room. And you'll receive an email that says you just created a room for the dental exam room. And I have a sample one here. I'm going to open up the sample one real quickly here. It went to the SEPS data, grabbed the latest list of equipment, went and looked for the latest generic template, built a new template on the fly with the latest equipment. In this case, we have 2 rooms. I had requested this, and it has a date stamp too. This was created 98 days ago, so there's a what we call a freshness stamp, because if you create a new one, it's basically going to the database and generating the latest one right here. From this, and this is again on the web, you can do several things. You can launch it into multiple applications, including our system, the Onuma system, or you can say, I want to grab this and take it out to Revit or SketchUp or create an Excel list. This is a live view of the room right here. And it has data associated with it as well. So if I click on it, you'll actually see information in the dental exam room, and I can drill into it and actually open up and look at the equipment all in a web browser. So this makes it accessible to non-BIM users. This is BIM, but BIM in a simple format. And if you open it in Revit, you'd have the exact, and this is what we're going to go into next. As we go into seeing these same information in Revit, the user can view it here, or click on a room, for example, and there's a dental chair. Look at additional attributes like information about the type, or the information about the additional attributes about this chair. This is the type information that's basically going and grabbing the latest data from the object, and we'll look at this later again in Revit. So let's see. From here, there's a couple other things. So this is a generic room. It's still not an actual project or an actual department. It's a single room or multiple rooms with the space and equipment aggregator tools. The same thing can be done for departments. So you can say go to a department, and I'm going to put my email address again in here. And from this pull down, it's basically going into SEPS master tables, as they're called, of the typical departments that are available in VA. This is still not a project. It's a sampling of, not a sampling, an actual data of all the rooms that are available for dental service, for example. And now it's going to the web and basically creating from the server, going and grabbing every space and every piece of equipment for that dental exam room. It takes about a minute to actually assemble them. But let me go ahead and grab the sample one right here, and it'll build it on the fly from that data. And again, this one was made 98 days ago. So the concept here is that it expires if you let it sit for too long. It's basically if new information, new standards come online on the fly, the latest standards can be built and say, here's the latest dental exam room. And you can also create the Revit or the SketchUp model from that as well. So here's a dental exam. All the spaces color-coded by function, and there are all the pieces of equipment. There's 1,271 pieces of equipment built from a database. So this is BIM built from the database into the project. Okay, so I know that we have quite a few VA planners on the call today as well too, so I'm going to show something that's familiar to a lot of the VA planners. We're going to open up SEPS itself to show some examples of how this works going out into BIM. So what we're going to do next is go into SEPS. This is what the VA and the Department of Defense Military Health System use to define project requirements. And we have a sample project set up here. So if I go into Project Builder, I'm not going to explain the functionality of SEPS. This takes a whole training course in itself of how to use it. It's incredibly powerful, but basically you input requirements and you input statements like how many patients are in this clinic, how many patients do you see a day, how many clinicians do you have, and it starts creating programmatic requirements to the space and equipment level. So this is for a simple clinic, and inside these clinics you can actually see conference room, for example, and the criteria and the contents of that room. So it lists the objects that we talked about earlier. It's basically listing, here's all the equipment that you need in this conference room. From SEPS, and this is important for the SEPS users, all you really need to know to be able to get this data out into BIM as a SEPS user, as VA, if I put the hat of a VA planner on and I go into the reporting function, there's a reporting function, and in reporting there's all kinds of PDFs and Excel files, as we all know, in SEPS that you can be, give me a list of equipment, give me a list of spaces. At the very bottom there's a button called Project BIM Export Excel. If you click on this and you select Export, it goes and grabs the data from the SEPS database and creates an Excel file on the fly. I'm downloading that. There it is right there, just downloaded it. So it's on my desktop. I basically grabbed all the programmatic requirements from that project onto my desktop. And I'm going to jump back to the SEPS2BIM website that we saw earlier. And there's one more tool I want to show. It's called the Project tool. This one, now we're crossing over into it no longer being a generic requirement, but actually being a specific project. In this case, you actually do need a login, and there's a way to get a free account that's fully functional. You can actually test this out yourself. There's a sample file that you can actually try if you don't have access to SEPS. That Excel file is right there. But I'm going to go ahead and just walk through this quickly. I'm going to call this project, let's call it DC Clinic. I'm going to put a clinic in DC. I'm going to search on the map for DC. I landed in DC, and I'm going to find a good open site somewhere. Oh, here's a nice big green area here. Let's just put it right here. This is the property line of the project. And then right here, I'm going to go and choose that Excel file that I just downloaded from SEPS. There it is right there. It's 174K. And I'm going to hit Proceed. And what this does is, again, going to the server and actually creating a link and giving you back a result of a project, which we will show next in the process going into Revit. Okay, so let's jump away from that. So it's no longer a generic project, but now it's an actual project with a layout, a default layout, which can then be moved around. So I'm going to log into Onuma now. So we're switching interfaces now. We've actually logged into the Onuma system. And this particular project, I prepped it this morning a little bit, but we've been working on this to connect it to Attainia. But once we're in Onuma, the generic layouts, the rooms will be stacked off in the corner like this, but you can start moving them around and actually start to do a quick layout. And from a programming perspective, this project is not yet designed, but it has the programmatic requirements and the project-specific data that came from SEPS inside it, including all the names of the spaces and the names of the equipment and the attributes of the equipment. So there's no manual typing to get it into BIM. You can continue to work in Onuma system like this, or you can go and export this into other applications as well. But let's take a look at one room here. I open this room up. Thomas, is this the right? Are you online, Thomas? I just want to make sure I'm going to be opening up the right room that you're going to be showing in Revit next. So Thomas is going to be playing.
Yes.
Yeah, go ahead.
Right. Actually, we're opening up the room right below that.
Right below that.
Right.
Okay. Yeah, we're focusing on for today.
I'm also gonna do the one with the left with the bed and all that. So yeah.
Okay. Okay. So what Thomas is going to be doing is he's going to be playing the role of the architect, and I'm going to be playing the role of a planner or an owner that's saying here are our requirements. But before we switch over to Thomas, let me show a few things here. So one thing is on the SEPS side, the data that we saw in SEPS, like I mentioned, is now inside this BIM, and the names of the spaces and the equipment is the same, And also, if I go inside the space and open this room up, it loads the equipment of that single space. The Onuma system, like I mentioned earlier, is a web-based system. You log in, you can have a username and login so it knows who you are, who has a right to access information and even edit it. To go into edit mode, I have to have a certain level of access. So if I go into edit, it's going to allow me to move things around. And it also allows me to look at the same information in an iPad application as well too. So you can actually say, okay, I want to look at it on the web, or I want to look at it on an iPad and see the same information there as well too. So let's see. Let's look at one piece of equipment here, this one right here. If I double click on that, and if you look at the names, these have all been populated from the SEPS data, so no typing was happened here. This is, as you bring it in from SEPS, it has all the attributes associated with it and has the type information. If I click on type here, it brings up the attributes that came again from SEPS of that piece of equipment right there. So there's the information from SEPS that's inside the piece of equipment, and we'll see this later in Revit as well. And that's the main point here as we show you this, is that the same information that is showing up here is going to show up in Revit and in SketchUp and in Attainia. As we make changes, we can actually edit things and move things around, do some quick studies, or we can say, let's look at the same project on an iPad. Let me open that up next. So the point is that you don't have to have a specific application to use it. We want to be able to look at it in any format we want. And here's the actual clinic that I just created on the fly on the front of the White House there, with the objects that came from that request. There's several hundred objects in here. This is before it's laid out, but this is automatically generated from Seps2BIM, and in an individual room like this, the same thing here. You can actually point to a specific piece of equipment, get the data on it, and this data is the same data that came out of SEPS. So this is the SEPS data that is now in this piece of equipment, created in the last few minutes as we built this project up. Very important point here from a designer's perspective. This is not a completed design. This is an owner requirement that shows you the requirements of this particular clinic, and the designer obviously still has to do layouts and even delete or add or change a room size. This is not the final requirement. This is kind of what is known from SEPS and from the VA or the military health system as far as their templates go. So the designer's task now is to actually resolve this. Actual product information has not been put into it, so you'll notice that the geometries of these objects are intentionally kept very generic. We don't know what the manufacturer is, and when you start going into more detailed design, the medical planners come on board. Obviously, this has to be swapped out, and that's what we're going to show next as we transition into Thomas showing this sample project I showed earlier going into Revit. So Thomas, are you ready to show your screen?
Yes.
One thing as you're switching over, for those online, if you have any questions, you can type in your questions into the GoToMeeting chat or question box, and Young will be collecting them. We might need to respond to questions after the webinar, but if there's any burning questions as we're going through here, we depending on time, we'll try and address them. So Thomas, go ahead.
Okay.
And I'll talk through this as you're presenting it, and if you want to jump in, but so this is the Revit model now that has the same project that I showed earlier that we generated from Onuma. In Revit, there's a free plugin you see along the top, the Onuma plugin that allows you to import the data from Onuma and also link live to the web service from Onuma as well. And Thomas, do you want to say a few words about this?
Right.
We're looking at?
So this is the same lamp that you clicked on in the other in the Onuma tool, but at the same time we have the whole entire spectrum of objects here. Same thing that you showed, and now if you talk quickly about the data in those files, I want to quickly show. So originally, when you look at those objects, that's the family in Revit that is being loaded. There's no information. There's no type information. There's no specific instance information for that piece of equipment. But once you have it in here, this is that same bed that I just showed. And if this is loaded, this is actually a mattress. I can't. So here's the bed. In this case, you get all the information. You get the instance-specific GUID that is coming from SEPS, but you could also get the full range of data from SEPS that Kimon was showing in the online system. So this is now coming. It's populating, and it even creates the parameters on the fly while it's importing into Onuma. So you use the import button. This is being created, this project, simply by importing that BIM XML file with the plugin. So you get this plugin here and you import the file. You select it and import it. I'm not going to do that here. Once you have it in Revit, you can start resolving it. You can go to the 2D views to modify it. You can put in walls and lay out your project here. The data in here is, if you now look at this, we see the data in the individual objects, but we can also go and see if there is additional information coming from Onuma by clicking on the Onuma data button here. This basically pulls from the web, from other applications, pulls information in here. Now, in this case, we're looking at some work that has been done on the planner side in Attainia now. I'm not sure, Kimon, but I think I need to jump here already into that concept that now we're looking at somebody actually having imported this same clinic into Attainia and having created a project in Attainia and assigned specific information. If I go and look at this bed, for example, at the data here that comes from the web service, I can see someone actually specified information here in Attainia. There's Attainia information, and this comes directly from Attainia. So if somebody in Attainia now goes into the project and modifies this and says, no, I want a different, use a different bed, they can do that. Over
so
here.
So one point here, actually, if you can open up that interface again.
Yeah. Right.
Very important point, and I actually posted this yesterday as a comment. Conceptually, what we're saying here is that data relating to this bed is actually not embedded inside the BIM. It's coming live from another source, including the SEPS data that we saw earlier. On top of Attainia, there's a SEPS data that came from the Onuma server. And then Attainia is another server, the medical planner, that's actually making decisions about, alongside as a designer is making these choices about the bed. The Attainia medical planner is actually saying, well, this is the type of bed that should go into here. And that data now, from a Revit user's perspective, we're actually seeing the same information in Revit, even though we don't need to know what's happening in the background. Right. This allows, if this data was hard-coded in the Revit family, you would not have this capability. You'd have to manage it manually. But we're saying keep the data attributes to a minimum and link to the authoritative data source, whether it's owner requirement data or we're jumping ahead here now to the medical planner actually making the decisions.
Right. And actually what we've seen here is that the SEPS data is being imported into the model so that you can afterwards create schedules and all that, but at the same time here, when you look at the same data here, this is coming directly from the server, from the web. So this is not the same. It's the same data because I created this project just very recently, and so I pulled in the same information. But if you open the web service connection here, you actually see the live data from the web and not anymore the static one that was generated when the project was generated. It's still not static in the sense that it was like 2 years ago added to the equipment, but it was generated when we created the BIM XML file to create this clinic. So there's different levels. Some information you might want in the model because you want to create electrical schedules in your model for the whole building, and so certain things you need in the model. But most of it, you can always get back to the original data coming from SEPS. If I now go in here and I say, okay, actually I do want to get more specific because the Attainia planner has specified that this is a specific bed. In this case, I'm actually using saying, okay, they decided to use a striker bed, so I can put this in here and I can place it now on top of there, but I'm going to place it next to it so you can see what's happening. So now we have here a striker bed that has information for product-specific information in here. This is the striker bed, so the team, but this wouldn't have to be necessarily a striker bed. This could be the planning team might have their own objects that they want to use in the modeling effort. They can use their own objects and transfer the information from the import from SEPS to this new object. So I'm going to go in here and say, actually, I want to transfer parameters. This would not be possible. You could easily transfer parameters if you go from one object to another. If you exchange the object, the instance information would be transferred, but the type information would get lost. But with this plugin, we can say, okay, I want to, from this object, I want to transfer it to the other object. And now I'm looking at the striker bed again. Now you see all of a sudden the instance information is here, the project GUIDs are in here, and in the type panel you can see that we have still the striker information, but at the bottom here we have the SEPS information in the same striker bed. So we can transfer this information over to the new objects. This could be, as I said before, special objects that the design team is using, or it could be manufacturer-specific objects. And I could now delete this bed, but I keep track. So I have now the correct bed in here, but I keep track of the correct information in this model. So I can always go back and create delta comparisons with the original project. I can do this even in here. I can say, click on the component tracker, and it compares the information what I have in this model here with the one that's online, basically the requirement. So if I remove objects in here, they will show up in the component tracker and say, hey, there's pieces missing in here, or the designer has removed those on purpose, or he has added equipment. So the same information that we looked at before, or over there in the, for Attainia data, you could see the same thing here. If you look at the light here, or we look at now at this wall-mounted Spiegel. What is that? Spiegel manometer. I'm looking at that now, and I'm clicking on that web service button to get Onuma data, and I can see in there again the same thing. We have Attainia data down here, specific Attainia data. That was specified by the planners. But the object still has just the normal SEPS information in there. Okay, now I can do the same thing. I can look at this in, of course, in the 3D view here. That same information you can see here. Of course, we have the striker bed that was added here, and we can also go into another application and look at this in Navisworks. So this is the same thing in Navisworks, the same clinic, and if I look at the object here, I get the bed, and I'm looking at again. This is again pulling data with the web service. I get again the same information from SEPS here with the web service, but I also get the information from Attainia. So we can connect to any kind of, and of course these plugins. This, for example, is to transfer the parameters. That's something that was done in a couple of hours in the afternoon before the last hackathon. because we wanted to demonstrate this possibility. This does not have to be anything with Onuma. This can be done by anyone who creates plugins for Revit. They could create those connections. The main thing here is really just the data is not residing in the early stage of the model. You're importing that data and you're connecting to the data without actually having to have outdated stale data in your model.
Thomas, there's a question that actually came in that's probably relevant at this point. Is AEs seem to prefer their own objects to limit file size? Using the live imported data would seem to bloat the file. Is this an issue? And I know that we've gone through this quite a bit as far as how to manage file size here. These objects are generic from, and like we mentioned earlier, they're not product specific, but if you replace an actual striker bed, it might have more geometry. But these generic objects have options to manage file size as well. Do you want to address that?
Right. We can even go one step further. If we talk about the file size is not really an issue. If you have a Revit file with lots of objects in there, if they're repeated, the file size only increases by one time that object. It's not duplicating that. But we also have possibilities that the main problem comes into this when you start to look at 3D. If you have a large project and you have all this 3D information in there and you want to open it, it's more a question about your graphics card than anything else. So we do actually have now are working on, and we've done it for these objects here, but not for all of them yet, so that you can go into a course view here, or course view, and you can see this in 2D. So you could go and then change your view for the whole building into a course view, and you can move around really quickly without having the problem of the 3D geometry. But the elevations would still, if you go in here and you look at an elevation, you still have the 3D objects. So the objects are still there, but in the 3D view, switching the course view, I don't see them anymore. So those are possibilities that we've developed just now to be able to manage large buildings when you want to see them in 3D.
And the architects, if they have their own library, own Revit families, or just like you showed the replacement of the striker bed, that's why it's important that we're saying if the data is outside of the object and you can transfer the parameters like Thomas showed, you can essentially transfer, if you want one room that has some highly detailed objects in the operating room and you have your own Revit families, the goal here really is to understand the programmatic requirements that came out of SEPS, and obviously you still have to be creative about your design process and what objects you use, but as you can start tracking these as changes happen, tracking it all the way back to the original requirements. The GUIDs that came out of SEPS, for example, are tracked in these objects. And with the transfer parameters, you can actually transfer to any object you want.
Right. And then the SEPS, the objects that we use, those families in the templates, they are kept quite simple. So they're not, this is probably one of the most elaborate objects with those wheels, but in general, we kept them quite simple. So you don't have very large, you don't get very large file sizes. And you can try that yourself. If you basically create a block of an object, of a family, a simple bounding box block, and you create an object like this, the file size is almost the same. That there's just overhead in Revit. If you create any kind of object, it has a certain minimal size, and that's going to be what you have in your file.
Right. Okay. Should we switch to Michael? Is there anything else? Continue to talk here, but there's obviously a lot more detail to this. We wanted to give an overview of what's possible here, and there's a lot more to this than just this, but this is actually incredibly powerful because essentially you can start populating, and even from the first few minutes of a project, you start seeing things to react to, and then you can continue to refine the model in various tools. In this case, Revit, Navisworks, and Onuma was shown. In the background, the medical planner from day one could even get involved instead of waiting till middle of the project or later on, and that medical planner might be making decisions about a piece of equipment that might affect the architecture, the layout of the room, or the structure. A boom arm from the ceiling needs more support, things like that. But we'll focus in on one room right now and switch over to Michael.
Right.
If that's okay.
He actually has the same thing here. The same SEPS clinic was imported into Attainia, so you will see this in Attainia.
Yeah. Okay. Great. Thanks, Thomas.
Okay, so first, background on Attainia. Our system is for capital equipment planners, and it's built on top of a catalog database that has over 45,000 products that basically span 5,000 categories and 25,000 suppliers. So a large data set that we have a content team that manages that and keeps that up to date. Our users don't have to, essentially, and they can pull this information, as you saw Thomas showing, that as the equipment gets specified along the life of a project, that information is vital that all parties can see. So obviously the goal here is to make sure that the equipment planner, working in parallel with the architectural engineer, can be working in parallel and getting real-time data and having communication as needed around that. So as was mentioned, we do have, this is an exam room that did come in from SEPS, so we do have the ability to import from SEPS into Attainia, and that's the generic JSN information and the the requirements for the project itself. And from there is where the equipment planner can then start to specify the actual equipment. As mentioned, we also the GUIDs we were referring to, those are the source of record from SEPS, and as long as ourselves and Onuma and Revit and everyone's referencing the same GUID, same identifier, we can pass data back and forth and be talking back and forth with this data, which is sort of where the power comes from. So what I have here, and we're just going to give a short demo. We only have a little bit of time here, but I've gone in, and in our exam room, I've selected this table, exam table, and what I'm going to do is I'm going to go ahead and search our catalog, and what it's doing is it's coming up with a list of potential products that we can go ahead and select. And so I'm just going to select one here, and we actually just drag and drop the piece of equipment in, and it'll actually be specified. And then from there, I can save that information. And what just happened was I, as the equipment planner, went in and saved the piece of equipment, and it is now updated the data on our side that now any of the BIM tools, the Revit, CAD, or Onuma, everyone else can now see that same data in real time, as I've done that based on the new requests. One thing I do want to highlight is as we go, I believe there was an exam light that Thomas had shown from here. This was specified, and within our products tab, as you're looking at the equipment, we actually have a product image, all the relevant attributed information on the product itself, including the physical data. And again, this is specified now from the more generalized GSN information that's given to the actual physical attributes, all the utility information, and then we have the product tech spec, these things as well. So here's an example of one of the product tech specs that you can get right from the equipment. So all this is basically a point of decision. All the information, attributed data, is right there for any needs that are there. So and that's, once again, the data came in from SEPS. So this was a SEPS imported project. It is then begin to be specified as decisions are made around dollars and cents, and also around spatial requirements, things like that, working hand in hand. Hopefully, in the future, that's what we want, is the architectural engineers to work more hand in hand with the equipment planners and have less cost at the end of the project as changes need to happen, and catch those earlier on and save costs essentially in the long run. Back to you, Pmo.
Okay, great. Thanks, Michael. And one thing that's significant here, and maybe actually, Michael, before you jump off, is this was developed, Attainia was the first vendor that came in with a web service link in this way to their data, and this happened relatively quickly after the SEPS2BIM web service and the BIM connection through Onuma and Revit were created. And that's the part that's most exciting about all this, is once this data is accessible, then other consultants and vendors and BIM applications can link to it just like this. There's nothing that really limits it other than deciding what makes sense from a use case. This particular use case is interesting because Attainia in this scenario actually can be made accessible earlier on in the process to the designer if it's part of the project. And the release of this, maybe Michael, you can explain, this is in development still. We've actually have a functioning version of this, but the actual release of this particular link to Attainia is going to be in fall sometime, correct?
Yeah, so basically what we have is a working prototype that we've been working with the VA on and going through and demoing and showing the active functionality, prototyping it to make sure it was going to provide for the needs of what we wanted. And so now we're in full development of this, and Q4, look to be releasing this in Q4 and moving forward from there.
Great. So we look forward to that. And we're getting a lot of excitement around this functionality, and we think that it's going to help owners and VA that uses tools like this to track equipment. And it doesn't necessarily, Attainia is great, but if other owners are using their own database of equipment, it's not really limited to just Attainia. But obviously this is the first example of it functioning in this scenario for SEPS. Okay, so I'll flip back to my screen now. Actually, okay, there we go. So one thing, maybe since we left off with Attainia, I want to show one thing here. I'm going to jump back to the iPad. Can you see my screen? Yeah. Okay. So this exact same room that Michael was just talking about and that Thomas was just talking about is visible in the iPad.
Simon, we see the wrong screen.
Oh, sorry. Okay, there we go.
Yep, that's better.
All right, so this is on the Onuma iPad app. It's a free app on the App Store you can actually get and link to these same projects. Again, non-BIM user in this case, but might be needing to review the equipment. So when I click on this lamp here and select the data button, you'll notice that it's streaming down here at the bottom. It's actually linking, again, live to the Attainia database, and the decisions that Michael was making are now visible right here as well, too. I can't edit these here, but I actually can see the decisions that are being made, which means more stakeholders can actually have real-time access, regardless of what tool they're using, to the different applications. Okay, there's a lot more to this. The Onuma system, you can actually already today, you can go online and to the Seps2BIM site and get a free account, a sample account to actually try some of this live. There's also the free utilities that I showed earlier that are driven by the Onuma system connected to Seps. The connection to Revit, there's a free plugin from Onuma as well. And the connection to Attainia is coming in Q4. We're working on it right now with Attainia, updating the linking and the workflow and talking to VA. And in our previous webinar, we showed SketchUp. So we're not going to spend a lot of time with SketchUp today, but I wanted to show you one thing here that's pretty interesting is maybe I'll start actually in reverse here. Everything that we showed you that was in SEPS, in Onuma, in SketchUp, in Navisworks, the exact same data is in SketchUp. So in SketchUp, there's the exact same lamp, which means that I can be in SketchUp and I can move this lamp. And if I save it back out of SketchUp, there's a plugin in Onuma, from Onuma that actually allows you to save back out from SketchUp back to the Onuma server. It'll show up in Onuma, and it could even be pushed back into Revit, which means non-BIM users can start to actually interact with the same data. And in SketchUp, too, the actual data is here as well. Ryan, are you on? Do you want to say a few words about this? Because this was pretty significant. The Revit families, the 1,000 families that were in Revit, were converted to SketchUp, placed on the 3D warehouse. And go ahead, Ryan, tell us what happened. And we have the whole webinar from last time online that you can watch in more detail. But Ryan, give us a few teasers here.
Thanks, Kimon. You know, it's funny, I've been playing with the model the entire time and making a few different scenarios and actually loading those up to Onuma to do comparative studies for 2 different layouts of the same space. So I was able to accomplish that during this whole time we've been talking. And that's really the point, is that this ease of access to this data for the planners is accessible in SketchUp, and it allows them to quickly make some decisions, look at things, and then load it back into the system and get some reports and share that with other people who may not be necessarily needing to see it in 3D, and maybe they like working in Onuma, maybe they like working in Revit. And so we're really seeing a neat fluidity between all of the different platforms because of this neutral aspect, and we're really excited to participate in this. So this is a lot of fun.
Thanks, Ryan. And there's going to be a lot more to come, a lot of really exciting developments here on this side. It starts to accelerate when you start seeing a lot of this potential here with many different applications working with each other. And then one thing that maybe I have to end with is in SketchUp, the file that I showed earlier that was on the web, if we go and say, okay, we want to import it in, what happens, instead of going to the 3D warehouse and manually downloading each of the objects that go into the exam room, the import to SketchUp actually starts building it on the fly and grabbing. See how it's listing down here? It's actually going to the 3D warehouse, grabbing the actual object. Sorry, it's off screen at the moment, but it'll come into screen in a second. But basically, it places them in the room from the 3D warehouse. There are a few questions that have been coming online. Let me pull this off the side as we process it a little bit. The question is, as a project develops and specific equipment replaces SEPS equipment, can the list of room be compared back against the SEPS requirements? And that's the whole intent of this. If the owner requirement, if we're looking at the owner requirement here, and as a designer I go in and change the size of the room, or take a piece of equipment out, or replace another piece of equipment, because everything has a GUID, in the Onuma system, for example, we can do a color coding of color code all rooms that changed in size, or color code equipment that was added or deleted or listed. And the same thing in Revit with the plug-in to Onuma. We can then compare the owner requirement that came out of SEPS now to our current design, because these models, as they come out of SEPS, are definitely not the final design. These are the owner's requirements with a ton of data in them about, you know, the type of room, the type of equipment, the attributes of equipment, and even down to you know, finishes and things on the DoD side. There's other attributes about the rooms, and BIM is really great at processing a lot of data. And if you have a control model that says here's the owner's requirements, and you're designing the model, whether in Revit or Onuma, you can start doing a comparison from one to the next. So we're down to the last few minutes. I really encourage everybody to track. We'll try and respond. We're getting a lot of questions here online, so we'll respond and send out responses to everybody. But I do encourage you to go to the SEPS2BIM .org website and try the tools that we talked about. There's training material online. We're in the middle of what we call a BIM storm, a healthcare BIM storm, which we're going to be expanding, which is a great place to actually get training on how to use a lot of this. There's some very basic things that can happen with, you know, non-BIM users, and really powerful things that can happen with those that have the BIM applications that can crunch through all this data. But sample files are online. The hackathon we were just involved with. So there's a ton of material here about what's been happening and where you can jump in. And we encourage you to continue to watch what's going on. We're going to have some more webinars scheduled in the future, including a full Attainia webinar when that gets ready in Q4 with the links to SEPS2BIM. And so we thank you very much for being part of today's session. We'll get through all your questions and respond. And this has been recorded as well. We'll be posting the recording on the training tab of SEPS2BIM, and the SketchUp webinar that was previously recorded a month ago is also in the training section. So you can actually see all of the videos right there as well. If you have any comments or input, we welcome them. If you have other types of owners that are looking at this as well, this is definitely not just for healthcare, definitely not just for SEPS. This applies across all owner types, all project types, and the teams that have been online today would be really excited to talk to you about that with other architects and engineers or owners that are interested in finding out more. Please drop us a line, and excited to see this evolve. So thank you very much for joining us today. This has been the SEPS2BIM webinar number 2, focused on Attainia, Revit, Navisworks, Onuma, SketchUp. Thanks to Michael Blair from Attainia for presenting, Ryan Gear from SketchUp, the Onuma team, and we'll see you at the next webinar. Thanks for joining.